Extrapolation methods. Extrapolation was used in section 4.5 for the approximation of definite integrals, where we found that by correctly averaging relatively inaccurate trapezoidal approximations, exceedingly accurate new approximations were produced. In this section, we will apply extrapolation to increase the accuracy of approximations to the solution of initial value problems. As we have previously seen, the original approximations must have an error expansion of a specific form for the procedure to be successful. To apply extrapolation to solve initial value problems, we use a technique based on the midpoint method.
This technique requires two starting values, since both W0 and W1 are needed before the first midpoint approximation, W2, can be determined. One starting value is the initial condition for W0 equals y of a equals alpha. To determine the second starting value, W1, we apply Euler's method. Subsequent approximations are obtained from 5.43. After a series of approximations of this type are generated ending at a value t, an endpoint correction is performed that involves the final two midpoint approximations. This produces an approximation W sub th to y of t that has the form
where the delta k are constants related to the derivatives of the solution y of t. The important point is that the delta k do not depend on the step size h. The details of this procedure can be found in the paper by Gragg. To illustrate the extrapolation technique for solving,
assume that we have a fixed step size h. We wish to approximate y of t1 equals y of a plus h. For the first extrapolation step, we let h sub 0 equals h over 2 and use Euler's method with w sub 0 equals alpha to approximate y of a plus h sub 0 equals y of a plus h over 2 as